Good afternoon. This is Krishna Sarvepalli. It's great to speak at a conference like this, especially AWS, and along with my fintech peers. It's the place where you're going to meet great and brilliant people, improve networking, share best ideas, and also occasionally pretend to understand every acronym that you are aware of. Earlier, I came across a term called CWS, which I tried to remember multiple times, still I couldn't able to. Today's topic, I'm going to cover about global payments, how the digital transformation journey that we have accomplished and we are going through from last 4 years. I have a very small agenda. I'm going to talk about how the current systems are working in the on-prem world and what are our goals to migrate to the cloud. How did we architect for the cloud solution? How did we enable multi-region architecture with DynamoDB and global tables? And I'm going to talk about generative AI, without which we cannot complete a session. About myself, I have a decade-long fintech experience where I'm leading the architecture for digital transformation journey of global payments. I'm a dynamic leader who is taking care of multiple complex solutions, providing the capabilities with scalable architecture, and I'm responsible for building high-powered enabled teams with strategic execution and effective planning. Along with that, on a side, I'm pretty good at photography as well. I try to take pictures, sometimes with head cut off. Honestly, I try to take some good pictures. Out of 10, probably it's gonna one definitely gonna come good. That's what I'm aiming for. And about global payments, it's the number one issuer in the world. We operate across 100 plus countries. It operates both issuer and merchant side of the business. Today we're going to talk about issuer. And we are number one in US, UK, Canada, and Ireland locations. We have close to 885 million accounts within our environment. So that's huge in terms of when you look at the number of requests, the number of transactions, number of odds that are processed by the system, it's huge. We process close to 67 billion transactions per year. Sorry, 75 billion transactions overall merchant and issuer, whereas purely for issuer, we process close to 37 billion transactions. Now let's dig deep into our use case, how it is working currently in the mainframe world. We all know about authorizations. Whenever an issuer issues a credit card to the customer uses the credit card for buying goods at a merchant location, contactless payments, your wallet payments, your chip-based transactions. It's going to go through Visa, MasterCard, and all the debit platforms. We support consumer, commercial, and debit platforms, all the three. And then we are responsible as a processor to approve or decline the authorization on behalf of the banks. So our current architecture, which is running in the mainframe from last 40 plus years, by exchanging the data with networks. So it all starts with networks, Visa, MasterCard, Amex, and debit platform networks. We have two mainframes within our world. One, we call it as an IBM mainframe, which is responsible for account customer card data, issuing the credit cards, customer service platforms, workflow management, a lot of other solutions are built around it. But the entire authorizations platform, we subdivided and standalone created a separate mainframe, which provides high throughput and low latency capabilities. Currently, it supports close to 3.6 billion transactions per month, and all the 100 plus clients are being supported from there. So now, how does these two platforms going to work out? When an account gets created in the second, which is IBM mainframe, those accounts get transferred over the batch files. That's why you see the batch file mechanism there, to HP nonstop system on a daily basis. So when an authorization is processed, the settlement going to still happen in the IBM mainframe. So the work is divided. So there's a constant data that is getting transferred between HP nonstop and IBM mainframe over the files, over the real time, over IBM MQ. Now, how did we solve this for the cloud? First of all, what are our goals? When we want to go with the digital transformation journey, especially for a platform like authorizations, where it requires 100% availability, high throughput, low latency, resilient architecture, how do you come up with your goals first? How do you define the goals that's going to meet your business needs? The first and foremost, when we talk about the cloud, without security, it's not going to go. Tokenization plays a crucial role. So how do you make sure that your PCI data, your PII data, your card number, address, first name, last name, all these, how do you make sure that your cloud persistent stores are compliant enough to handle any of this data? And the second one is, with mainframe, we operate in North America and international, but our goal is how do we expand to other markets, other geographic locations where we are not currently operating it. And the third one, which is very interesting, very innovative solutions that we have built as part of the platform, not specific to authorization, says plugin capability. Plugin capability, I'll just explain one simple example. All of our clients, especially in 2025 we are talking about, they are interested in building their own secret sauces in terms of the authorizations. So how do you make clients to be part of your auth decisioning? How do you make a call out to the clients using a simple contract oriented approach? How do you make your solutions available for the clients in a real time fashion for the integrations? That's what the marketplace and plugin capability. It's like an app store that we are making it available for our clients. And the next one is SaaS based solution. Authorization, along with authorizations, all of our workloads are multi-tenant. Requires so much of complex configurations to onboard a client, to enable any features, to perform any canary management. All these, how are you going to make it available using a simplified self-service capability with effective guardrails? And the last one is, we're talking about multi-region capabilities. We're talking about burst capacities in the cloud, because we don't want to spin up for all the load from the day one. We want to solve for Black Friday. We want to solve for Thanksgiving. So how do you handle the burst capacities using auto scaling capabilities? How do you provide a resilient architecture for any region failures? So these are our high level goals across the platform, not specific to authorization itself. Now let's look at the high level architecture, how we have created for the distributed side of it. Left side, it's not going to change. Networks, Visa, MasterCard, and debit networks. It's going to interact with a platform called Auth Gateway. Gateway is like an entry point which abstracts the data, which takes the connection management. We establish the connection with the Visa, MasterCard over ISO 8583 and TCP/IP connection. So how do you abstract that ISO 8583 and provide the future capability? Tomorrow, how do you handle 20022 when the networks introduce that across the globe? How do you take it to a place where ISO 8583 with a Swift-based payments, with the solutions that you're going to build, you don't want to refactor, re-architect again and again. Once gateway receives it, it takes care of all the common functionalities. For example, any of the cryptographic related works, client detections, routing strategies, all of them will be handled by your common platform and routes the traffic to your middle layer decisioning area. Decisioning, you can see consumer, commercial, debit, because we all know consumer, whatever that we request to the banks, that's a consumer card. Whatever that we get over the company or corporate, that's a commercial card, and we all know about debit cards. So there are variety of rules that needs to be processed from each of the systems. Once you receive the request, you have to make sure your funds are available before approving or declining. Then you're going to interact with your value-added services, your fraud detection strategies, your risk-based assessments, your card control capabilities. All of them will be integrated and make it available. On the bottom, you can see there is an interaction with the mainframe. So as part of the solution, we built only authorizations in the cloud for settlements, which is the second coin of an auth, is still running in the mainframe. So that's what the need for the Kafka and making it available in the mainframe. So from Kafka, there are multiple consumers are available. One is going through mainframe. Second one is going through data lake solution, where we are generating our analytics, reports, dashboards, our billing strategies. All of that will be executed at one single unified place. Now let's talk about multi-region architecture. Earlier we talked about high availability. That's what drives multi-region. What's going to happen? We all know that cloud is definitely reliable, available 99.9 percentile. How do you make it to next step? How do you make it 5 nines availability? That's what the architecture is mainly intended for. So especially auth being a tier 1 architecture that is needed from regulatory standpoint. How do you support a multi-region capability? Let's look at little deep into each of the regions. We deploy our workloads in US East 1. We have a VPC there. We follow Kubernetes-based containers mechanism for all our deployments, all our microservices. And we deployed auth gateway. We deployed auth decisioning platform. And routing between these two components are based on NLB, Istio, and gRPC-based communication. We leverage that to achieve long-lived connections, high throughput, and low latency capabilities. On the side, you can see DynamoDB. We leverage DynamoDB currently for managing the transaction data. All of our auth platform balances all of that information, account data, customer data in the cloud is managed by DynamoDB. We leverage multi-data stores. Along with Dynamo, we leverage Oracle as well. Oracle is managed mainly for configuration based. So any of the client configurations that are managed over Oracle, we have the capabilities for reload, refresh, all of that is needed when a self-service has changed any of the configurations. We leverage KMS to manage the PII data. So data encryption strategies are managed over KMS keys and KMS AES-based solutions. And the last one is Kafka. When an authorization is processed, we're going to take a look at in the Dynamo whether the customer has enough balance or not. We're going to approve or decline the authorization. Once everything is done, we're going to respond back and tell, hey, auth is approved or declined. And asynchronously, we're going to put a message. We call it as a cloud trial kind of an event that we're going to put it onto the Kafka from entire ecosystem. Here, auth gateway and auth decisioning both going to publish that event message. Now, let's move on to the US East 2. It follows exactly the same semantics. There's no difference. The interesting part here is when you are going with an active region, how do you make your data available in both the places? That's when the global table is going to come into the picture. We leverage global tables to replicate the data between two active regions. And we are maintaining the data in third region as well for a DR capability. So currently we operate in active, and also a DR capability where we are making sure that the persistent data is available when the entire US East grid is down. So as part of the global tables replication, it provides 3 copies of the data that is available in region 1. It also maintains 3 more copies of the data asynchronously in the second region as well. We solve the data aspect of it. Now, how do you handle the connectivity mechanism? What will happen if a region 1 is down or the region 2 is down? How do you handle the connectivity? So what we did with working with the networks, MasterCard and Visa on the debit platforms, we have established the connectivity from both the regions. So since this is a TCP IP socket-based solution, the connectivity originates by the payment processors, which is GPN. We establish the connection from both the places. Whenever a region is down, the second region is still available to handle the traffic. There are health checks going on back and forth. Both Visa and MasterCard are going to do the health check with us, and we also going to do health check with Visa and MasterCard. whenever a line is down, we're going to operate at a 50% capacity, and we have health check systems built into the region level, identifies the whole region is down. It's going to kick off the auto scaling mechanism to bring up to the proper capacity. So you'll see a disruption of 50% of the traffic for 10 seconds, which is nothing but our first health check, and our second health check within 90 seconds, it's going to spin up the corresponding nodes on the second side. We operate both in an active-active fashion. So we talked about data consistency, we talked about high availability, and we solved for low latency as well by establishing TCP/IP based connection mechanisms over direct connect, private VPC endpoints, and NLBs, NAT gateways that are in between MasterCard and GPN networks. Let's look at other architectural patterns that we have implemented. When we talk about cloud, we are all familiar with 6R strategies and also the strangler pattern, how that's going to help us out to have the business continuity in the on-prem world, but still take piece by piece, workload by workload from the mainframe and make it available in the cloud. As earlier I have mentioned, we are serving close to 100 plus clients. Disruption is definitely not a good idea. But when you are building for digital transformation journey, which will going to span across 4 to 5 years, how did you generate the revenue? By incrementally building the workloads in the cloud and take one by one workload at a time in the cloud. So this architectural pattern talks about the same. How did you extend the on-prem solutions and connect it to the cloud as well? So I'm going to take about the use case of auth decisioning, which is our second container. Auth decisioning talks to DynamoDB for transactions, Oracle RDS for configs, and it's going to talk to MSK for any asynchronous communications. Now you have another service, which is auth async service. That's going to consume the messages from MSK Kafka. It generates a different structure, reduces, it got some raw data, converts into a structure that is needed by different systems. It interacts with the tokenization service, because when we talk to on-prem world, we need to make sure that we have clear data, because cloud is the only place where we have tokenization applied now. Once you get the necessary message structure, you're going to communicate over direct connect and send that to on-prem data center. This is the one that I was showing earlier, that we have an interaction from cloud to the mainframe. The use case, what we are talking about here is auths or authorizations are processed throughout the day in the cloud, whereas settlements are still happening, or settlements and clearing are still happening in the mainframe. So what we did was we pulled only auth system to enable in the cloud. Our settlements, which establishes the connection directly in the mainframe, directly to the Visa MasterCard with the mainframe itself. Now we exchange those messages. There's a service again in the on-prem that gets the message, converts that into RTDS packet which mainframe needs, and make it available in the mainframe. The important thing what we all need to understand is the pattern that we have in the on-prem, it's a backward compatible pattern. Our existing current auth, which is taking care on the HPNS and sending the settlements, hey, this is a auth that was processed in the morning for $10. You're going to make it available for the mainframe. Evening, you're going to get with the tip or some additional information as a batch file, which you are supposed to settle that. So that information we kept as it is in the mainframe so that we can replace easily in the cloud when we modernize other half of it. So we talked about the real time. So throughout the day, real-time auths are happening. We are continuously feeding the data, make it available in the mainframe. That's all good. How do you solve the recon process? How do you make sure that you are 10 million auths, all the 10 million auths went to the mainframe for the settlement aspects of it? What will happen if there are failures? What will happen if there's a network glitch happened? That's when actually we started building a recon solution with a batch-oriented approach. Throughout the day, real-time auths, we're going to stream it, make it available in the mainframe. At the end of the day, we're going to take the same data and generate a batch file and make it available in one shot to the mainframe. So that is for the second one. So we leverage Apache Airflow, Spark clusters, and S3 buckets, where we are generating the files and making it available. And using Connect Direct, we are making those batch files available on the mainframe. So throughout the day, morning, on the step 1, it is getting real time. On the step 2, it is getting over batches. Now, the settlement details, the auths that are available in the mainframe, what is the next step? Now the settlement is going to come into the picture from networks. Networks going to send you, there's a settlement file. Once you receive the settlement file, then it's going to look into the mainframe and figure out what is the corresponding authorization and do the settlement. So that's how actually we have achieved the strangler pattern, taking half of the workloads without disrupting the clients, how we can migrate to the cloud. And I'm going to talk about one more use case, which is very interesting, especially for folks who are mainframe background. They can understand mainframe is batch-oriented solution. Either you're going to get a file over the FTP or NDM-based approaches. You need to wait for a day if you want to take care of any of the data points. You need to, for example, the new records came into the picture, you need to wait for the next day. All these various situations that you need to encounter. How do you solve that in a distributed world? How do you make any changes that happens in the mainframe? How do you make any changes that happens for the account, customer card, a new account got created, a fraud has been detected, a account status got changed? All these informations, how do you make it available to your customers as quickly as possible? This is one of the streaming pattern that we have incorporated. We built a streaming engine. That streaming engine is responsible for capturing any changes that happens in the mainframe or in the distributed world. It's going to structure the data, make it available in the Kafka. So now the data is available in Kafka. So how do you make it available for your customers or clients? You'll have various types of clients. A client who is collocated next to your AWS account, AWS clients, a client who is non-AWS client, a client still in your data center. How do you provide all these connectivity capabilities using a simple pattern-oriented approach? So that's when the team has started looking into it, and they leverage either direct connect, VPC-based approach, Equinix Fabric, all these different various networking capabilities, connectivity patterns are defined and made it available. So when we want to onboard a client, all we do it is over the Kafka, we expose an NLB, we go through one of these connectivity patterns and make it available for our clients. And the next one I'm going to talk about is, as I mentioned, without AI, it's not going to get completed. So I'm going to cover about a little bit more on the regression testing strategy and how we have leveraged SageMaker-based solution as part of it. So when we started the journey almost like 2.5 years back, at that time, we all know that AI has been boom from last 1.5 year pretty heavily. All of the testing strategies that we have built is based on automated solutions, but it's a one step low for developer fixes. So we built close to 3,600 plus test cases as part of regression testing strategy. When we talk about regression testing, it's not just like a simple JUnit test cases. We're talking about whole end-to-end authorization scenario we're talking about. So all these executing on a daily basis, spinning up the clusters, execute with DynamoDB, validate the results, and make sure all the test cases are in good shape. That's what we are doing it. And later, after working with AWS, what we figured out is, how did we change this solution, make it a little bit more effective? When a test case has failed, how do you make sure that the fix for the test case, a recommendation is already available for a developer so that they can identify and fix the issue immediately? And our regression is a point where, if at all, if you want to move the code from version 1 to version 2, it has to go through our regression testing strategy. So that's when you're going to get the confidence saying that, hey, there is no breaking changes from the new code. So as part of that, what we did was, when we run the regression suite, if there are any failures available, we're going to execute a Lambda. From Lambda, it's going to capture whatever the failures that are there. It's going to generate the corresponding embeddings for it. And that embeddings will be semantic search with PG vector database. That's where We preloaded all the earlier recommendations with failures, and now it's going to figure out what is the corresponding match for it, recommendation candidate, and make it available for the developers. So with that, the first thing that you need to do it is, for all the 36 test cases, you know exactly what kind of failures it's going to run it into. Let's say it was unable to connect to database, it couldn't able to perform business validations, it was unable to perform some integration points, there is HTTP 503 issues are coming, 404 issues are coming, all of that you're going to figure out and preload the data. Now, when you run it into any of the issues, you'll be able to directly get the recommendation out of it and make it available for the developer. Pretty much we are on time. And the last one I'm going to cover is business benefits. We talk about the whole authorizations platform, but the entire architecture that we have built is not specific to one platform. It's for the overall digital transformation journey. So the first and foremost is security, which is definitely needed for our compliance and enterprise security, enterprise standard standpoint. And the availability aspects of it, we talked about the multi-region architecture. We are aiming for 5 nines. We are at 99.99, and we are working towards it. How are we going to make it 5 nines? So with the multi-region, high availability, low latency capabilities, with the data using global tables mechanism, how we were able to achieve, that's another benefit. And the next one is improved troubleshooting capabilities. Earlier, we talked about eventing strategy that we have built. Entire digital transformation journey follows one unified mechanism of tracing. So that events loading into the data lake and generating the reports out of it, providing the analytical dashboards on top of it, provides a lot more unification across our observability stack. And the next one is agility, speed to market. That's what going to generate a lot more better products. So what our goal as part of the digital transformation journey is, how do you launch new products as quickly as possible? That is what one of the business goal that we have received. And the last one, which is very important, as the digital transformation journey, it progresses years, probably 4 to 5 years or next 2-3 years. How do you make sure that you're not disrupting your existing on-prem workloads, and provides the business continuity and provides the revenue generation model with the new products that you're building in the cloud as well? That's all I have. Thank you.